I'm trying to share my screen. There we go. All right, so 4.3, once again, is just a re-emphasis or of 4.1, 4.2. Just taking what you learned in 4.1, 4.2 and bringing it all together. Maybe adding a few more steps. So we have 14 times the quantity of x plus 1 equal to 2 times the quantity of x minus 11 minus 60. All right, so the first move is for us to distribute. So it'll be 14x plus 14, 2x minus 22 minus 60. I actually can combine like terms. On this right side, I have negative 22 and negative 60. It'll be a negative 82. Now that I have everything simplified as much as possible on each side of my equation, I notice that I have an x term on each side of my equation as well. At this moment, your goal should be to get each term that has x on one side of the equation and each term that does not have x to the other side. So we can subtract 2x. Cancel out on the right. Oh, so that'd be 12x plus 14 equal to negative 82. Subtract 14. $12x equal to negative 96. Now we can divide both sides by 12. 12 cancels on the left, leave me with x. And on the right, negative 8. All right. Questions on that one before we look at another one? All right, so here we have 2 times 2x minus 6 minus 3 times 3x plus 2 equal to 3 minus 3 times x plus 3. All right. So first move, just like before, is distribute. We're going to distribute 2 here. Here, be careful. We're distributing -3. Don't forget to distribute the negative. And here, distributing -3 as well. So that's 4x minus 12 minus 9x minus 6. 3 minus 3x minus 9. All right, so now on the left side of our equal sign, combine your like terms. -4 and -9, oh, excuse me, 4x and -9x is -5x. -12 and -6 is -18. And then on this right side, we have 3 and -9, which would be -6. And that's minus 3x. All right, so we have x terms. When we get them all on one side of the equation, terms without x on the other side. So I decided to add 3x. -2x minus 18 equal to -6. Add 18. And it's going to be 12. So we have -2x equal to 12, and then finish it off dividing by -2. X is equal to -6. Don't think I mentioned last class. If you're having issues or unsure about your signs, adding, subtracting, multiplying, dividing, sign numbers, you know, shoot me an email. I think I have a pre-made video that I talked about that, you know, short video, just to give you a reminder of it about sign numbers. So always feel free if you need extra help or extra assistance or something like that. Feel free to email me and let me know. All right, questions on that one before we look at another one?
I do.
All right.
So on the top of how you got -5x, how did you get that?
Oh, we did positive 4x and -9x.
Okay. I
Yep.
was just wondering because the way that I remember I was like plus 9x, then plus 9x, and that's how I was gonna like add 9x to both sides to cancel out that one.
Oh yeah, you can do that. As long as when you add the 9x, that you add it to the -3x on the right.
Okay.
Yeah, as long as you're combining your like terms, you're still fine. It's just that on this left side, since I had 2x terms, I went ahead and combined those so that I'm just taking one term to the right, because at some point that 4x will still need to be combined with the x term as well. You know what I
Mhm.
mean? So yeah,
That
you
makes
you can
sense.
do it that way. Yeah, you'll still be fine as long as you do everything right mathematically. There's sometimes there are multiple ways of doing it.
Okay, I think you.
No problem.
I'm not seeing something. I got negative 5x minus 18 plus 3 equals 3x plus 3x minus 9. I'm trying to figure out where I messed up at.
All right, so you said negative 5x minus 18, so you got that part
Plus 3.
plus 3.
That's
Now, so after the equal sign,
it should be
okay,
3x minus 9.
it should be after to the right of the equal sign. Originally, we had this right here, 3 minus 3 times the quantity of x plus 3. So it should have been 3 minus, when you distribute, 3x and then minus 9. So after this step right here, what did you have this step?
I miswrote it. I see. Let me write that down real quick. I miswrote.
Okay. Okay, cool. Yeah. That'll do it.
Let me write this down real quick.
Yeah, you're fine. You're fine.
So it's minus 3.
Mhm. Let me know when you're finished.
X minus 12 minus 9. X minus 6 equals 3 minus 3x minus 9 minus 5. Okay, I'm good.
All right. So let's look at where we're going now. Okay, yeah. Doing another problem. So the next one, 6w minus 5 over 5 minus 3w
I hate
plus
these.
2 over 5. I'm sorry, sir. Equal to 1. So notice our denominators are the same. And we want to get rid of the denominators if possible. And we can, because we can multiply each quantity or each term by that 5. So let me see how I want to write it. Let's go black. So everything need to be affected by that 5. We're not multiplying top and bottom by 5. We are multiplying just across the equation. So we're only multiplying the numerators by 5. All right. So what's going to happen now is that the 5s will cancel, leaving us with 6w minus 5 plus 3w plus 2. Then on the right, 5 times 1 is 5. Hold on. I did something wrong.
Yeah,
I went from minus to plus right here.
yeah.
Apologies. That should be a minus sign right there. So let me erase that here. So now whenever we have a minus sign right here, that adds a different dynamic, something that we have to be careful of. What actually happens here is that that minus sign needs to be applied to each term in that numerator. So when I look at my original equation right here, this minus sign is not just applied to the 3, it's applied to everything that's in the numerator that follows. And so a lot of people make the mistake in giving that negative to just the 3, and they forget to give it to the 2 back here as well. All right. So 6w minus 5 minus 3x. Oh, not x. So used to writing x's. Minus 3w minus 2 equal to 5. All right. Questions on that before we go to the next step?
That -5 goes multiplied by that 2, right?
You talking about this one?
Yes.
Yes, but because we have this 5 right here, it cancels before we get to it.
All right, thanks.
So now if you wanted to distribute, no, I'm just saying, just if you wanted to before you cancel, you could distribute 5 times 3 and 5 times 2, but this 5 will still be down here. So
Got
then
it.
once you finally reduce, it'll still bring you back to that,
Got it.
3w.
Thank you, Professor.
Not a problem, sir. So now we're in position that we can combine the like terms. 6w minus 3w is 3w. -5, -2, -7. That's equal to 5. Add 7. 3w equal to 12. Finish it off by dividing by 3. All right, questions before we do another one?
I got one question.
Yep.
I got it wrong.
Okay.
So you take the negative sign, the 5, you just cancel out the 5s.
That we're in the denominators, right?
And just take the negative sign and multiply that -1 times each number in the parentheses.
Yes.
So that 2 changes from to a -2.
Yes.
Then you take that 5 and just multiply by the 1 that's past the equal sign and just make it a 5.
Right, because it didn't have a denominator that would cancel it out.
So that 5
So
is automatically assumed to be positive.
say it one more time, you went out.
The 5 is automatically assumed to be positive.
Well, that's because that's what we did. We multiplied each term by a positive 5.
Okay.
If I wanted, if you just wanted to make things more complicated, you could have done -5. It would have came out to be the same. Say again?
I'm trying to keep it simple.
Yeah, but if you would have chose to use a -5, as long as you multiply each term by that -5, just like we did a positive 5, you will still keep your equivalency, and your final answer will still be w equal to 4.
Because I had a problem doing this while doing the homework. That's why.
Gotcha. Yep. So yeah, we shouldn't be multiplying by a negative. We should be using positives.
Here we go.
All right, let's do another one like that. Let's go 5x minus 2 over 6 equal to 4 minus x over 1 over 3. So 5x minus 2 over 6 equal to 4 minus x. So I'm going to give you guys a chance to try it out, see if you can get the see if you can get the right answer. And I will give you the hint that our LCD is. Anybody already see it?
It's 6. Oh, my
Yes.
bad.
No, you're fine. You're fine. Yeah. LCD is 6. So when before we multiply each term by 5, this time we'll multiply each term by 6. So I'll give you a few seconds to start it, try it, and then we'll walk through it. All right. So, like I mentioned earlier, I'm going to multiply each by 6. All right. And from there,
Okay, I have a quick question.
all right, what you got?
Why are we multiplying 6 times 4 if that, yeah, why are we? I don't even have
Okay. I was about to say, did I lose you? Well, I'm thinking you're saying that since it doesn't have a denominator.
right.
Uh-huh. Well, whatever you do to one side or whatever you do to one term, you have to do to all, or you're changing the problem completely.
Uh,
So in order to keep your equivalency of your problem, whatever you do to this 5x, you have to do to the 2, you have to do to the 4, to the x, and to that -1.
okay, all right. So that's let me redo my.
No problem. Trust me, a lot of people make that mistake. A lot of people make that mistake. So you're not alone. All right.
I think
Mm-hmm.
I got -4.
For the answer?
Yeah.
Oh, well, I don't know what the answer is. I'm just picking out problems, sir. So we'll find out.
Okay.
All right. So 6's will cancel. Leave me with 5x minus 2. Nothing cancels with that 6 times 4, so that'll just be 24. And then here, I have to be careful. The 3 cancels into the 6, but that leaves us with 2. 6 divided by 3 is 2. So this is what we have so far after the cancellation. Distribute -2 into your parentheses. All right, so that's -2x plus 2. And we can combine these like terms over here. Any problems so far? So now we have x terms in multiple places. Is that a question?
Yeah. So that negative did that negative go with the x?
Are you talking about this negative?
But yeah, by the 24.
Oh yeah, this negative is attached to this 2 right here. So it goes, when you distribute it, it goes into the parentheses, and then it gives you negative 2x.
All right.
And then also, negative 2 times 1 will give you a positive 2.
All right.
So your signs are normally attached to the term that follows it, not the one that's before it. All right. So let's add 2x to both sides. That'll be 7x minus 2 equal to 26. Add 2. Seven x equal to 28. Then finish it off by dividing by 7.
I got that wrong.
Well, no, sir. Did you say you have negative 4?
Yeah.
Well, just messed up on a negative.
Okay.
Yeah.
Y'all have a minute? Can you hear me?
I can hear you, yes.
All right. I did. Can you start at the beginning of the problem? What I did was I put the 6 on the outside, and I put it in parentheses.
Okay.
All right. Then I did 3. 3 were going in 3 one time. 3 were going in 6 2 times. Then I took that 2, multiplied it to the 4, and multiplied it to the negative x, and multiplied it to the negative 1.
Okay.
Right? I get to my second row is 5x minus 2 equals 8 minus 8x minus 2.
8 minus 8x minus 2. Well, you could have, I know what I showed you, doing it this way is the simplest way of doing it. You could have gone a certain way with the way you were explaining it, but you shouldn't have come down with 8 minus 8x minus 2.
Okay.
Yeah.
That's where I screwed up at.
Say that again?
That's where I screwed up at.
Yeah. Yep. So I would suggest just sticking with just that one number, whatever your LCD is,
Okay.
and then just multiplying that to every single term and then reduce from there. And then so when you look at, this type of situation right here, when there's something left over, you know what's left over and you know what needs to be multiplied. Same thing with this 6 and this 4. As long as you just multiply by the same number across the equation, everything's guaranteed to work out,
Thank you, Professor.
Not a problem. I think I heard somebody say they wanted to do another one like that. Okay, not a problem.
Like when I'm doing my homework, I have the example in the corner that's in the book.
Uh-huh.
And I had a problem, and I try to do the problem. I'm doing the problem at the same time as the example.
Mm-hmm.
You know what I'm talking about?
Yeah, uh-huh.
So it's like you said, it's repetition.
Yep, that's all it is, man. That's all it is. And if that ever worked out, it's called muscle memory. You work out so much that your muscles remember it, jump shot, all that. Same, it's all be referenced to the same thing. Just repetition. All right, so let's do another one. Let's see. I see something in the chat. Okay, so I will send you that code in a few minutes. Let me finish with this, and I'll do that for you, sir. Or if I didn't see it, hold on, I didn't look and see that was a sir or ma'am. Sorry. My apologies. I didn't even look. I just said sir. So let's look at it. We have 3n minus 5 over 5. minus n minus 11 over 6 equal to 3. LCD is, anybody got it?
30.
Yep, 30. So I'm going to multiply each, just like we did the 6, just like we did the 5. Going to multiply each by that 30. And when I was referencing the 6 and 5, I was talking about previous problems.
Now, with at the negative sign, I would just put a 30 on the other side of the negative. Okay, I see.
Mm-hmm. Yep. So everything should still be there except for the 30. Everything should still be there, and you're just putting a 30 in front of each quantity.
And in front of the 3, I'm putting a 32.
Mm-hmm.
Okay. Now, automatic see, I can reduce 30. 6 divided by 6 is 1. 30 would be 5. You see where I'm?
All right, so say that one more time.
All right. I can reduce, not reduce, but 6 will go into 6 one time. 30 equals 5.
Mm-hmm.
Yeah, I take that 5 and multiply it to the n and multiply it to the 11. Am I correct?
Yes, because
That's
when
a
we do it, say it one more time. You keep going in and out.
that's a positive 5.
Now we're in front of the 3n, or you talking about in front of the n?
In front of the n minus 11.
Now the result. Now when you're talking about 30 divided by 6, that will be a 5 right here. But because of this negative,
So that's a positive 5.
right? But because of that negative, that negative is attached to the 5 when you do your distribution.
So a negative 5 times negative 5 times n times
Negative 11. Yes.
positive 55.
Yes.
All right.
All right. So let's make sure everybody's with us. So that 5 divides to 30 leaves you with 6 in that first quantity. 6 divides into 30 leaves you with 5 in that second quantity. So before I do the distribution, I will have 6 times 3n minus 5 minus 5 times n minus 11. And we can go ahead and do 30 times 3, which is 90.
Thanks for being patient with me, Professor.
Yeah, no problem. You're fine. Not a problem at all. Hold on 1 second, guys. Somebody's saying something to me. Got to make sure things. Sorry about that. I had to make sure that wasn't an emergency. So let's go ahead and distribute 6 and then negative 5.
Get 18n
Mm-hmm.
minus 30
Yep.
minus 5
Mm-hmm.
plus 55 equals 99.
90.
90, sorry.
Yeah,
90.
yeah. No, you're fine. I just had to make sure we were seeing the same thing.
I just want to make sure I got a clue.
So now we can combine the like terms. 18n minus 5n, 13n, negative 30, positive 55, plus 25. That's equal to 90. Subtract 25. (13n) is equal to 65. Then we can finish it off by dividing by 13. n is equal to 5. Questions, questions, questions. All right, let's do at least one more. Let's see if I have some decimals involved. So we have 0.8 times 5a plus 61 equal to 4a plus 48.8. So if we wanted, we could get rid of the decimals. If not, you can always just work with the decimals as you see them. Doesn't matter. I'm pretty sure most of you are using your calculators. But let's say if I want to get rid of my decimal, I can multiply each term by, how can I say it, multiples of 10 according to how many decimal places I have. So because I have one decimal place at the most, even when I look at here, then that would be a 10 that I will multiply the equation by. So if I had 0.75 and I want to get rid of the decimal, I would multiply by 100 because of two decimal places. If I had 0.758, then I will multiply by 1,000 because I have three decimal places, and so on. So it just depends on how many decimal places you're trying to get rid of. That's how many zeros you would put behind your 1 in order to take care of that. But once again, just remember, whatever you multiply one term by, you have to multiply all terms by in order to keep your equivalency. So if I wanted to get rid of the 0.8, like I said, I will multiply by 10. Also, just re-emphasizing the fact that if you don't even want to worry about canceling out your decimals, you don't have to. You can just work with them. But just showing you another way of solving your equations. Ran out of room over there. So the 10 times the 0.8 turns that into 8. I haven't done my distribution yet. Ten times 4 is 40. And then 10 times 48.8 turns that into 488. All right, so now let's distribute. $40A, and that's what, 40, not 40, but 488. All right, just so happened, I didn't know that this was going to occur. We have one of our special scenarios. you notice that when we subtract 40A from each side, variables will cancel on both sides, leaving you with just 488 equal to 488. And we talked about this last class. I believe we did in this class. We have a true statement.
Okay, I have a question. So
Yep,
we
yep.
wouldn't continue to like the A wouldn't drop down to just A. Okay, hold on. I'm sorry. My nephews are in here. Excuse me.
It's okay.
I told you. Okay, so I wouldn't drop the A to just make that A and then move the 488 over and that just be 0, so A equals 0.
No, and that's a common mistake. If 40A minus 40A cancels on one side, then that has to happen mathematically on the other side as well, because 48 minus 48 is going to cancel, be 0 regardless. Right. And so a lot of people are afraid to let your variables cancel because that's not normal. The only way that A would be left is if you were dividing by. Then you would have, 1A left. But when you do 48 minus 48, that's 0, whether it's on the left side or right side of your equation. So what we can't do is say, okay, on the left side, 48 minus 48 is 0, but then on the right side, 48 minus 48 is A. You see what I mean? So if it happens on one side, then that same thing happens on the other side. Then if they cancel, then that's fine. That's just what it is. Yeah.
Professor Tucker.
Yes, sir.
When I'm doing a homework assignment, I think to put the answer in there, you just got to put brackets, I think, or something.
What you mean?
When I had a problem like that doing the homework, and I thought the answer would be 0 because they both cancel each other out. But to get the right answer, I had to put the 2 bracket things in there to get the correct answer. You know how it gives you 3 times to do it?
Yeah, when you click in there, it gives you the option. Yeah, you have to click on. Well, let me see this. Hold on 1 second. My kids are bringing the interference. Give me 1 second. All right, sorry about that. Okay, so oh yeah, we're looking at the solution. Let me try something real quick.
I think it's in the homework.
Yeah, I'm checking something. No, I just typed in the answer and it just took the number 4. Now you can use those symbols, but when you just type in the number, it accepted it.
Okay, maybe I'm recollecting it wrong.
Yeah, try it out. If you see that and they give you an error message or something like that, screenshot it and let me see what it says, and then shoot that to me, and then we'll go from there.
I got to figure out how to do that.
Well, do you have a phone that can take pictures? Well, you can just take a picture of your phone with your phone and then email it to me from your phone.
That's what I did last time. I took a picture of my homework.
Yeah, that was you, right? Okay, yeah. So that's fine. All right, so let's finish this one off. So the answer isn't true. It's just that we have a true scenario. In other words, 488 is equal to 488. So we talked about this, or we finished off last set of notes. If your variables cancel, and then you have a true statement. That's supposed to be statement. I got real lazy with that. Your answer is actually all real numbers.
Okay. And that's one of the answers in the homework.
Yes. Mm-hmm. All right. Questions on anything? Questions, any questions, any questions? Everybody good to go? So, like I was mentioning to your classmate earlier, this is all about repetition. You know, getting those reps in, doing multiple problems, sometimes very similar problems, and coming across different scenarios so you'll know how to react to them when you see them. So try these out. Um, got the weekend to play with some more. That's 4-1, 4-2, and 4-3. Feel free to shoot me an email if I see it before class time. I should see it. I'll shoot you an email back. If not, then always can bring it up in class before we get into anything new, and we'll go from there. All right. Anything else before we close out?
I got a question.
Yes, sir.
When doing the homework assignments, I'm trying to find the right words.
Mm-hmm.
Should we go by the assignment date on the homework when it's due, or can we just take that pressure off and say, hey,
Oh, I meant to change that. I forgot. See, a course coordinator created the shell.
that's what made me push through.
Say that one more time.
That's what made me push through
Okay.
trying to get the homework done, because I was thinking, okay, I got to have this stuff done by August 31st. My question is, how can I say it? Do we have to worry about the assignment date, so we have to worry about the anxiety of making sure it gets done?
I'm about to change those dates now to December 11th.
You the man.
But at some point I will set a date for, like unit 1. All of unit 1 need to be due by this date.
Okay.
All of unit 2, but that won't be set until we get closer to closing out lectures for unit 1.
Like, I rushed through the homework, then I have to go back and do the assignments to make sure I got it.
Right. Yeah, so I'm gonna remove that. You don't have to worry about any due dates until I actually say there's any type of date to
Thank
be
you.
concerned about. Yep, no problem. I meant to do that beforehand, but thank you for bringing that up.
And that's why I don't, not to be too personal, that's why I don't grasp the concepts, because I'm rushing through the homework,
Mm-hmm.
worrying about the due date when I can't go through the assignment and practice each section.
Right. So I'm resetting that now. All right. Anything else? Anybody else before we close out? Oh, I see something in the chat. How can I access the homework? Oh, what's the name? Okay, I will type that to you. Just hold on. Lola O, I will type that to you after I make sure everybody else is good. So everybody good before we close off for the weekend? Then I address her. All right. You guys have a good one. Be safe. Try the stuff out. And I'll see you on Tuesday.
Have a good day, Professor.
All right, you do the same.
Have a good day, Professor Tucker.
All right, you do the same. Take care.
Okay, now let me figure out how to log out.